Hello everyone. Welcome to ROS 106 lecture series. This will be the third lecture, and let's recap what we have already covered. We have already covered that where do we use ROS, why do we use ROS, and how to create our own publisher subscriber, and the basic definitions and implementations of topics and notes. This is Hani. I am also a member of Robotics Club, and today we will be covering what are custom interfaces, and in the subtopic we will know that what are they, why do we even need them, with the help of some formal definitions and examples. And moving on to the next part, we will know about some new file types, which are the server files and message files. We will also write our own server and message files. And by the end of this lecture, you will be able to create your own services, the service client and server. We will come back later to that part. And what are we be creating today? We will be creating our own calculator using ROS. So let's move forward. Yes. Why do we even need these custom interfaces? Just why? We have publishers and subscribers which can get a data, which can hear a data, which can publish a data to a topic. Why do we even need custom interfaces? Uh, the definition of custom interfaces is very basic. Just like the name suggests, it's custom. We make them. And we need them because there are several other functions which we need, and we need to be flexible when working with ROS. We cannot completely depend on the default interfaces which is provided by the ROS. So we build those custom interfaces. And I know it's difficult for you to understand using this formal definition. So we will learn it using a example. So take example of a drone whose function is to identify plants, like based on color, it will identify the condition of the plant and decide what type of fertilizer it needs and spray the fertilizer on that plant. So, in completing this task, there are several things which the drone will need to perform. Move to a plant and move to a fertilizer. So, we need mobility, something which controls the mobility. Second will be image identification. The drone has to identify fertilizers and the damaged plants, so it needs image identification. The third is the type of fertilizer. As I already told you, there would be something which will help the drone to recognize that this fertilizer will be used if the condition of plant is like this. And the fourth will be spray rate. Let's first coming to the movement part, we have something like this. Geometry messages. This interface is provided to us. It has a twist, so it gives you the value of the position and the orientation. So it helps us in movement. And there is also an interface, the STD messages. I hope you guys are familiar with STD messages. We have already covered it in writing publishers and subscribers. So is this enough to create such an nice project, such an high level project? It's just simply not. You cannot do everything with these two. We need more. We need just more. So this was it. We will now move forward to writing our own interfaces. And for that purpose, we will use our own the construct.ai, the same thing which we have used in the last two lectures. So we will create a new ROS. We will use ROS2 humble and create from scratch. Give it any name. I will name it custom interface. You can name it anything and then run. So we will close the notebook for now and open our code editor and also our terminal. So yeah, in our terminal, we will go to ROS2 workspace and create a new package, just the same way we created packages in our last lectures. ROS2 package create minus minus build type. Now we can use either Python or CPP. I will be using C++. You can also use C Python for this purpose. And I will name this package at customs. So in this customs, we will be making our custom interfaces. It will create a message file and a server file. So we will come how to create our own files. So first we will create our own package. So the package is created. We haven't used the license. The license we used in the last lecture was Apache, but that's all right. You don't need to use license. So our package is created. You can have a look from here. So this is our package, the customs package. And in that custom package, we will create two new files. In that custom, create a new file and we will name it, not file actually, we will create a new folder. We will name it a message folder and one more folder, which will be our server folder. We will name it SRV. Let's say we name it SRV. So yes, the message folder will now have a new file. This will be our, let's say we name it operation.message. So this operation.message is our message file. Just in this lecture where you saw the geometry messages and standard messages, this is our message file. And in the server folder, we will create another file which will help us in creating our calculator. So whatever we are doing, this operation message and this server file will help us in making our own calculator. So you can say we have already started making our calculator. So these are the two files which we will need. So let's first jump to the operation message. So this operation message will have several parameters. So we will start writing our first operation.message. So first let me write. Then I will explain you that what are these things. So the first thing here, float n1, float n2, and a string operation name. I have used a short form ON for operation name. So all these three things here written in a dot message file are formally known as field names. These are the variables which will be used by our calculator. So which will be used by our calculator. Now, so this was the operation message. Now we will go to the .srv file and mm, make sure you pay attention to the file structure format of the SRV file. First, we will write operation O. That's not ON, that's O. Then there will three minus signs, and after that we will get a float 64 result. I am using rest for result, a bool success, and a bool valid. So this is our .srv file. Now we will now look at how these SRV file works. So first, the operation O is known as the part of the code block above these three icons is known as the request block of .srv file. So what happens in simple words that the SRV, the service client, is asking for an operation named O, and the code block below the three icons is known as the response block. So SRV asks operation O as a request and it gets a float 64 result, a Boolean value of success and a Boolean value of valid as a response. Now let's see. It asks for an operation O and there comes our operation dot message. The parameters are n1 and n2. So let's just ask after calculator asks for n1, n2 and operation name as add. So n1 is 2.3, n2 is 1.1. So and operation name is add. So what happens? We will get a result of 2.3 plus 1.1, which is 3.4 and a boolean value of success true because our operation was success and valid addition is valid. Now why do we need this valid boolean value? So we need this for error handling. Let's just say n1 is something and n2 is 0 and our operation name is division. So this is not valid, so there will our boolean value of valid will come to a play. Okay, so this was our operation message and calc.srv. We will now update our CMake list and package.xml. So let's just jump to CMake list. So this is our CMake list. There we will add some different types of things. So first I will complete the CMake list and then explain you about the functions and the packages which I have included in CMake list. We are done with our CMake list.txt and I will show you what changes did I make. I have added these two lines, the geometry messages. You are familiar with it. I have already explained in the earlier part of the lecture. So we will be needing it in our calculator. And also one thing, this ROS ideal. So going in depth of ROS ideal is not necessary and not in the course content, but you still should have some idea about what is ROS ideal. Now let's just see. You are going to write some, let's say, service, some publisher, some subscriber, some node, some topic. You are going to write it in a language specific code. You are going to use Python. You are going to use C++. But you are using operation message. What is N1, N2, ON? They are strings. They are English. This operation O, float, res. All of this is not understood by ROS by default. So think of ROS ideal as a middleman which converts these things, these information into a language specific code which is understood and which is compatible with your services, with your publisher, subscriber, whatever you are doing in ROS. So think of ROS ideal as a middleman which provides infrastructure to your interfaces. And yes, just like I said, the ROS ideal generate interfaces. These are the things, the message which we have created, the SRB which we have created. The ROS ideal will generate interfaces based on this. It will create a code which is understood by ROS. So this was enough for ROS ideal and make sure you make the similar changes to your CMake list and pay attention to the curly braces here. Sometimes it ends up in error if you mistake these curly braces for parentheses. So pay attention while doing that. And now we are done with CMake list. We will now update our package.xml. So yeah, we are done with our package.xml as well. I will again tell you the changes which I have made. We have declared our dependency geometry messages, which we will be requiring and some build tool dependencies, these ROS ideal default generators, and some executable dependencies, default runtime, and member of group, these interface packages. Now again, you don't need to go in depth with these dependencies, the ROS ideal default generators, the interface packages, the default runtime. You should have a shallow understanding of what ROS ideal is actually doing. And with these, we have completed our operation message, cal.server and CMake lists and package.xml. With this, our package is ready to be built and we will now move to our terminal. Go to your workspace, ROS2 workspace, and make sure to use Qualcomm build in your workspace and not in some other folders. Obviously, it would not end up in an error, but it makes your file structure a bit messy and more inconvenient for you to work with. So make sure you can Qualcomm build in this workspace directory. So we will use Qualcomm build. You can use Qualcomm build or you can build directly your own package with this package. Select customs. Now, if you only use Qualcomm build, it will build every package present in your directory. And if you use this minus minus packages select customs, it will build only your own custom. So this is just another command, doesn't matter so much. So we will do it. It finished quickly, but in your case, it will take some time. So you should wait for it. And with this, our package is built. Now we can move forward and create a new our own service, the calculator which we have talking about. And so again, so our package is now built. Now we will create another package for our customs, for our calculator. I'm sorry. So go to this and yes, back to our terminal. We will use the same command, ROS2 package create minus minus build type. Comment Python. And this is our package name, the calculator calc, and we will make the package with the dependencies which we have created. Dependencies, partial pi is our one of the dependencies and our customs. With this, we will create our own package. So our package is created. Again, we will getting something like a license declaration. You can ignore that. And after it's done, move to your code editor and you can see a calc here. This is our calc. And in the calc, we will create in this folder, there is a init file. In the calc, we will create a new file. Let's just say I name it server node.py. So this is our server node. So we are into the service part of the lecture. So I will explain what actually service is. So service, let's take an analogy. So think of service as a restaurant. You reach at the restaurant, order something, and then you get whatever your order was. So service works really similar to that. There is a service client, which requests, which orders, and there is a server which completes the task and sends the result back to the client. And just like in a restaurant, you wait until your order is complete. The service client will wait until the server is done with the calculation, the computation which you have asked him to do. So, how is it different from publishers and subscribers, which we have covered in the last lectures? So, publishers and subscribers are one way. Like, if you ask it to publish something, it will keep publishing something. If you ask it to listen to something, it will keep listen to something. It is not a two-way communication, but a service is a two-way communication in which you are asking for something and you are getting for something. So, this is how it's different. And we will now create a server node. So first we will import our messages from customs.srv. We will import calc. We have imported our .srv file, which includes the request and the response part. Like This calc will help the server node understand that what is asked by the client and what do I have to give in the response. So we are creating a server file. This file will do all the calculation and send it back to the client. So now we will import RCL file, and from RCL file dot node we will import node. Then we will create a class and name it service node, and it will inherit node. I am assuming that you guys have already covered the lecture 1 and 2 in those. uh, Object orientation programming in Python has been explained clearly, and also you have already used them while creating your own publishers. So I am guessing that you are comfortable with this. We will now create, right, def init and self. I am also hoping that you guys know what super is, and we are going to name it, let's say, server node. Self dot srv is equal to, we will now create our own service. Self dot create service, and let's say this is the service type, and our service type is calc, and service name, which is a string, we will name it calculate, and then a callback function. So we will name a service callback, but for now let's say dot self dot service callback. So our our service is created. Now we will go down and create our own service callback, which we have declared there. Def service callback, and it will take self request and response. Operation dot message is equal to request dot o. Now, this operation, so now we will write operation message is equal to request.o. Now, what is this request.o? This request.o is nothing but this thing, this O, the operation O. So we are creating a variable operation message which gets its value from the request part. As I've already told that this code block is the request part and this code block is the response part. So this operation message is nothing but the request.o, which it is taking from the calc which we have imported. Now we will move forward and declare some more variables. N1 is equal to operation message dot n1, n2 is equal to operation message dot n2, and operation name is equal to operation message dot on, and we will also use dot lower just in case we use capital add or small add, it does not make so much difference. And we will also create self.getLoggerinfo, getlogger.info, and let's just say we say perform operation name on N1 and N2. So our logger is also done. And it might be confusing that we are saying operation message is the request part of this SRV, and we are saying that N1 is operation message dot N1, which is here in the operation message. So once we are done creating our calculator, we will come back to this part, and then I will explain that how this request dot O gets access to the operation message. So let's just think like that. Uh, if I ask you for, if I request you for an operation, which is this operation O, I will obviously give you the field names, the variables which I require. So let's say I ask you that do a addition. Yes, I just say do an addition. You cannot do an addition like that unless I say do an addition on 3 and 4. So this request operation O actually has access to this operation dot message, which we are going to create later in this video. And obviously, don't worry, I will come back to that part and make sure you don't have any doubts left. So we are done this part, and now we will now come to the best part. If operation name is equal to add. Now we are coming to the response part of the calc.serve. Response.res is equal to n1 plus n2. Okay. Response dot success will be true. No problem here. And response dot valid is equal to true. So yes, we are now in the response part of this cal.srv, and we have just going to copy this. We are just going to copy this code block and paste it several times. If operation name is equal to, let's say I said subtract the and make similar changes to paste it again, say it mult, it, okay, if div. Now, now this is a nice part of the video. In the division part, we are going to handle some error. In multiplication, subtraction, and addition, you won't get any error, but in division, you get the division by zero error. So first we would write if n2 is equal to 0, what would it be? The There would be no result, so float 64 result is invalid. Using that is invalid here. The response dot success would be false. It's not success. And response dot valid will be false as well. Whatever operation you are asking me to do is invalid. So that would go there. In the else, we would go to response.res is equal to n1 by n2, and response dot success is equal to true. and response dot valid is equal to true. So this is, but uh, this is the division part, and there is something else left. What is that? What if you are asking me to compute the modulo? I have not made my computer, I have not made my calculator to compute the modulo. In that case, I would say response dot valid is equal to false because I don't know what computing modulo means. And response dot success is equal to false as well. And after all these service callback function, I would say return response, the complete response. So what are we returning here? We are returning response. It means we are returning all these three values. So that's also something you can notice. The ROS ideal which we were using actually creates something like a class for this response section and something like a class for this request section. Not actually a class, but really similar to this. So whatever you are doing here, this response dot success, the response dot valid, the response dot res, this operation message dot n1, uh, you you could have noticed that these things actually are working like class. So whatever is this is made with the help of ROS ideal. If you don't have ROS ideal, the Python does not know what operation message.n2 actually means and where do we have to look for these values. So this is why ROS ideal is really important. So let's just finish it really quick. We'll create a main. RCLPy.NET RGS is equal to, I will name our service node as service node RCLPy.spin. What it would spin? It would spin the service node and RCLPy.shutdown. And at last but not the least, if name double equal to main, what do I have to do? I have to call the function main. So with these 55 lines of code, we have created the server file, the server of our service. So the main function of this server is to actually compute the values which is asked by the client. So now I have someone which can calculate for me, but then I need someone who can ask for this. So now we will create a client, the service client. So as I already said that the services needs two things. One is a server and another is a client. The client asks for the response and the server sends the response. So we will now create, a client.py in the calc folder, and we are going to import something. Once we are done with this client.py. I will explain both the server node and client.py once again and tell you how they both combine to make your calculator. From customs.srv, I'm going to import calc again. I'm going to import rcl and now from customs.message, so from custom.messages, here we are importing this operation. We are getting a hold of all these field names, the float N1, N2, and operation name. Now are getting the idea what is actually happening here. This client has access to operation this N1, N2, and operation name, and this client also has access to this calc, the request operation O, mentioned here. Look at this name, operation O. So it has access to both the cal.srv and operation.message, and that's how the operation O is getting access to all these N1, N2, and string operation name. So as we complete it, we will get to know more about this. So we will create a client node which will inherit again node. In that we will use def init self super dot init, and let's just name it client self dot cli is equal to, we will now create a client self dot create client, and the srv type will be cal. Make sure we are using the same thing here. This cal can calculate, otherwise it would end in some sort of error. This calc and calculate, calc and calculate, and we are done. Now again, just like I said, if you are sitting in a restaurant, you give an order and you wait until your order is arrived. So same thing will happen here. While not self dot cli dot wait for service. Until your service is reached, you would wait, and I will set the timeout set variable as, let's say, 1. You are going to wait for the service until it's reached, and you are going to log it set.got logger dot info, uh, waiting for service, and now this is a nice part. Serve.reg is equal to calc.request. Now what is this? This rec is actually creating your request, actually requesting. This is what is actually requesting. The calc.request is operation O. And now we will create something which will send the request. Let's say we name it def send rec, and it will get self comma n1 comma n2 comma on. Self dot rec dot o dot n1 is equal to n1. Self dot rec dot o dot n2 is equal to n2, and self dot rec dot o dot on is equal to on. We will now create a future. Self dot cli dot call async, and we will now send our request. Now we will create a main function. Def main args is equal to none rcl by dot init, and another, let's say we say client, which will be our client node, and then rcl by dot, and then another future is equal to client dot send request, and now rcl by dot spin until future complete. So RCL5 would spin this function until the sending of request is complete. We would pass the node, the name of the node, which is client, and the future, and the node. Now, so this thing sends the response and waits, sends the request and wait for the response. Now, if future dot done, if future is done, the response will be future dot result, whatever result is obtained. Now, if response is not none, and response dot success. If the result is not none, and our computation was success, and also if our response dot valid is true, which means everything in this case worked fine, we would get client dot get logger dot info result is response dot res. Okay, so this is clear. Now in the else statement, if the response was not none, you get some response and the response was success, but it wasn't valid. So we would say client dot get logger dot info, and what we'll say, we don't need f print. Mm, incorrect operation type. Whatever you are asking to me do, I have no idea how to do that. Just like the case of modulo. And after that, there will be one more else block here. Else, if either the response was not obtained or it was not success. So in this, if the response was none, you don't get a response. We would say client dot get logger dot info. You are not getting any response. No, no response found. Let's say we just say that. And in the else, if you get a response but it wasn't success. Now see, the response is not just the result. The response comprises of both, all three of them, the response, I mean the result, the Boolean success and the Boolean valid. If you are getting a response, it means that you are getting at least one of them. Okay. So if you are not getting a response, then response is none. You are getting none of the three. But if you are getting a response, so it does not necessarily means that you are getting a result. You are getting at least one of the three things. Getting a response means you are getting at least one of these three. So let's come back here. If the response is not none, it means you are getting some response, but the success is false. You are not succeeding in it. So we will say client dot get logger dot info and operation wasn't success. Okay. Now we will destroy the node. Client dot destroy node and rclpi dot shutdown. Now this is the last line of our code. If name is equal to main, what are we going to do? We are going to call main. So with this, our client.py and our server node, our service is completed. Now let's just get a recap. Now just let's get a recap. So we are done with both our server node and client. So a small recap, we will go back to both of the server node and client.py, have a look at the program flow and how does our calculator works, and also look for some changes or some mistakes we made during writing this program. So first we will go to client because in the program flow the client is going to ask for something. So first we are importing import sys. This sys is used for our command line in terminal. Like in terminal, we are going to write 3 to add. So sys is going to use there, like yes, like this. So the sys helps us in knowing that in writing the three words 1, 2, and 3. So the first will be a float of n1, second will be a float of n2, and third will be a string of recent name. So this is just for our input purpose. From custom.srv we import cal. Now, have a look at here. The calc has a request of operation O. So this operation is a value and this is its type. So the operation O has a value of O and its type is operation, which is this thing. You can see that. The operation O is of type of this operation dot message. So this operation has N1, N2, and ON with it. This operation O has N1, N2, and ON with it. So basically what we are doing in our cal.srv, we are requesting in the form of this operation dot message. So let's get back to our client. We create a client here and we wait until we receive our response. Here we create a request. We create a request and yes, just like we can see, it must be a capital R. We are fixing this. So it creates a request and this thing updates the request. This will send the request by first updating it. First we go to O and we set N1 as N1, N2 as N2 and operation N at whatever operation we need from here. I think this is clear that why its operation has the same name as this operation dot message because this operation small o is nothing but this operation dot message. Next, we create a future which calls for the request and we return the future. The future is whatever the response we are getting. Now, if future is done and we get a response, so if we get a response, none value response, and the response is success, uh, if the response is valid, we give the user its result and else it must be a invalid operation which I told you the example of modular. The next, the response is none. We are not getting a response, so no response found and else. So these are just if else cases based on what type of response we are getting. So this was our client. Here clearly the client asks for something using this code block. Now we will move to our server node. Now in this server node, we have a service callback function. We again use that same O operation message type, and we update the operation message using this. And we are using lower just in case we are giving command in caps or smaller. So we are using smaller. And again, the if else, one more thing you can do is you can change the other if statements as elif. Oh, that's it. And yes, here also the shutdown is missing the bracket. So this was it for the server node and shutdown here is also missing a bracket. We will see if we are not. So here REA a spelling typo. So yes. So I think the client.py and server node.py is clear. and how client.py accesses server.srv file, and how the request operation O accesses these field values from operation.message. After this, we will move client.py to this calc folder and the server node.py to calc folder. So this calc should have this. Now we will update our setup.py. We will update the console scripts. So yes, in console scripts, we are going to add a name service, which is nothing but calc.server colon main, and we will also add another our client as client equals calc dot client dot sorry colon dot main, and with this our setup.py is also complete. Here setup.tools is giving some error, but that's fine, you can ignore that. So with this our calculator is almost complete. We are just need to build our package. So we will go to ROS2 workspace and use call con build minus minus packages, select and calc. We'll just wait for it to complete and it's finished. So this one package has std error output. It is because of this setup tools. So we can leave it for now. And now we will source our workspace, source install setup.bash. So we will source and we will use ROS to run cal and service. We are done with our setup.py as well. Now we will move to our terminal. So this is our terminal. In our terminal, we will first build our package. So the same all con build minus minus packages select. We are going to build our cal. So wait until it builds it. So yes, our package is built. Now we will need two terminals, one for calling the service and one for calling the, one for calling the server and one for the client. So we will source this as well, and we will source this too. After sourcing, we would call it ROS2 run calc and whatever name we used here, we named it service. cal service. It's sending in an error, module not found error, no module name cal server. So it's basically a error in your setup.py. Oh, here we are writing it at cal.server, but our Python file is server node. So you need to make a small change here and name it as server node. We will go back and we need to build it again. So it will take some time. Notice that this package std error is due to the setup.py. You don't need to worry about that. Uh, now we will source it again. And after sourcing, we will run the service. So as you can see, we have run the service and it's basically waiting. We have waiting for the client. We will now call the client. In this, we will call the client. So this is we will ROS2 run client and we will now give our commands. Now notice here that's why we use sys, the import sys. The first value will be n1, the second would be n2, and third would be the operation name. So we are going with 3. I would say that if we can split the terminal, it would have been fine, but let's leave that for now. So this is it. ROS2 run client 3, 2 and add. It is going to add and return 5. So here it is, the client result is 5.0, and in this side you can see that it's saying perform add on 3 and 2. So again, uh, we are gonna do something like this again. We are going to subtract and the result is 1. Yes, 1 minute. And in this side you can see perform subtract on 3 and 2. And we are going to run some more test cases. We are going to use div. We are using actually capital div and the result is 1.5. That's why we use lower. And here you can see perform division on 3 and 2. So these were the basic things which you can do. Now we will try to cause some error. So let's cause some error. We are going to divide with 0. So it's basically waiting for service. Operation wasn't success. So it tried to divide with 0, but it waited for service until it was trying to calculate something. And finally, it ended up that the operation wasn't success. Now we will do something like 3, 1, and we will do something which wasn't divide. We are trying to find the mod. So operation wasn't success. It just tried to perform mod on this, but it wasn't success. So this was your calculator. It seemed to work fine. You can also do some experiments. Try closing the service and then calling using this. So it's going to do nothing but wait for service until it gets one. But it won't get one as the service is not running. So our code here, where did it go? In the client, this waiting for service. This is what is working now as it cannot get any response from the server. It's just waiting until it gets a response. And we tried getting this. We tried getting this. This none operation is really rare as you are going to get something out of it. Either it's the success, valid or result. Uh, we are going to get to this incorrect operation type. When are we getting a correct? When we are getting a response and it's either not valid or it wasn't success. So let's just close it. And this was a nice calculator. We basically built our custom interfaces, use those interfaces to create a server and a client. And by now you have the idea that how services works. What are custom interfaces? We have already built a calculator. Now there will be some tasks which you should do, and I would say what else you can do as homework from this lecture is you can add more operations such as power, modulus, percentage, this thing. And also you can improve error handling. As you can see, it has a very basic error handling. Let me show you. Let me show you. Let me show you. Here. When I tried dividing by zero, it gave operation wasn't success, and when I tried mod, it gave operation wasn't success. So it's a really poor error handling. Like if I am doing division by zero, I should have get something else, and if I using an invalid command, I should have get something else. So you can work on the error handling as well. And one more thing, which you should do is try making the client interactive. You should be able to get user input. And with these homeworks, you are ready to work with services and making your own custom interfaces. So this was it for the lecture. See you in the next lecture, the lecture 4. So that's all.